Hi, so I saw a clip recently. Sorry for the angle, but this is how it's going to be. It was a Jack Sparrow clip, which is why this is called the Jack Sparrow problem. And essentially, in said clip, there's Jack Sparrow's daughter being held captive by, I think, her lover, but I don't know, I've watched like one Pirates of the Caribbean. But anyway, the captor says that Jack Sparrow's got to pick 2 guns to shoot, and he tells his men, the captor's men, load 6 guns. So there are 6 guns in total. And he says to unload all but 2 guns. So there are 2 live guns, meaning obviously there are 4 blank guns. So Jack Sparrow must pick 2, and obviously he wants to pick the blank ones because he doesn't want to kill his daughter. So I was thinking, like when I saw that, I was like, my first thought was, when I saw the size of it, I was like, oh yeah, I forgot this is like the 1800s, so you could probably like pick up 2 of them, and like assuming one was loaded and one was blank, you could like tell the difference in like the weight because of how large like the gunpowder was back then, like how much of it was in a gun. You could probably actually like physically like, using heuristics, just like figure out which one was live, which one was blank. The lighter one is obviously the blank one. So our first axiom, I guess, is that, not really axiom, just truth. I don't know. It's not really a statement. It's our first, assumption. Our first assumption. So first assumption is M blank is less than M live. So I was thinking, like, my first thought was like, well, after I thought this, I was like, oh, you could just weigh it out. I was like, what's the minimum number of guns that he would have to interact with before he could discern which ones were blank, which ones were live? And so then I thought about it, and I think I have the answer. I'll tell you once I show you my working, which I did on paper. So we have, for myself, I wrote it out like M1, M2, M3, M4, M5, M6, and then I put dots above the live ones so that I have a better idea. Just those are the six guns, each with different masses. The live ones are the ones with the dots above them. So then let's start testing our stuff. So I'm going to leave this blank for other assumptions. Actually, first, so you can't have, actually, I'll show you this. So this is for assumptions, okay? Assumptions. Actually, before I do all this, by the way, what do you think? Like, how many do you think? Because I was actually kind of surprised. I thought it would be more by a little bit than what I had gotten. But anyhow, so our first test, 1 gun. Could you determine if you were safe or not? No, because you wouldn't have anything to compare it to, so it's basically just picking at random. So, no. Equivalent to picking at random. 2 guns. Promising, but no. Also, pretty clearly no. Because you could end up, there's a scenario where M equals M. So both the guns you pick are equal to each other. That could be the live ones or the blank ones. So you would not know if you were holding 2 guns that are going to kill your daughter or 2 guns that are going to save your daughter. So, no. Cannot discern between 2 blanks and 2 lives. So 3 guns. This is where it gets interesting. Does this still look good, by the way? Let me check. This still looks good? Camera still okay? So 3 guns. We're going to have to add a second assumption. And I'm saying assumption even though these are literal, like, truths. Like, a gun that's loaded with gunpowder in the 1800s is definitely heavier than a gun that isn't. But anyway, so you cannot have a scenario like this, where M less than M less than m for like 3 guns or for any amount of guns, because that would imply that there were 3 different distinct m's, meaning there were 3 different masses. And for this scenario, there's just a live mass and a blank mass. So, because like we're assuming that, okay, yeah. There are 2 m blank and m live are the only 2 masses. No gradient between. So you aren't going to have like a half full gun. Because if you did, then things get a lot more complicated, and I'm assuming they wouldn't just half fill guns. I know that they tampered them and stuff, like it was pretty close, you know what I mean? I feel like this is a good assumption. That doesn't really take away, actually I feel like this is still pretty solid, like this doesn't really take away from anything, but anyway, 3 guns. So our first scenario of 3 guns, so I'm going to call it 1.1. First scenario is m equals m. You got 3 equal guns, you're safe. Because for 3 equal guns, you would need 3 of the same type of gun, either 3 lives or 3 blanks. Since there are only 2 lives, you can't have 3 lives, meaning these 3 must be blanks. I'll write only 2 lives to have 3 of a kind. They must be blanks. So 1.2, our second case. M less than m equals m. Okay. So I was like, for this, I actually moved on to 4 because I was like, oh, well, you can't discern anything. This could be live or blank. But then I remembered our axiom, the first one. M blank is less than m live. Meaning that if this is less than this must be blank. So that means that we know that this one is blank and we know that these 2 are lives. And since there are only 2 lives, you've determined the lives. So you know this one's safe, you know these one aren't, so just pick this one, and then the second gun, just choose any other than the ones you've already determined. So safe, you determined the 2 lives. And 1.3, so then we have m equals m less than m. So then this would also be safe because this should be a period. It's whatever. This is I'm not caring about spelling periods. But anyway, these 2 are less than this. That means this must be blanks. These must be lives because blank is less than live. So then that means that you have 2 blanks to choose from. So you determined the blanks. This problem seemed a lot more interesting when you didn't have the first axiom, and I'm pretty sure it'd be like 5 that you need to compare before you could determine, like, because then once you have 5, you know which one's live. Once you've already determined 1 live, you know the other because you have the other 4 already determined to be blanks. So there's only 1 possible solution, so I think it's 5 if you don't have the first axiom, but I actually don't know about that. That's an exercise to the reader, or viewer, or whatever you are. So then those are the 3 scenarios for 3 guns, I believe. Like you could have like this, but that's just the same thing as this scenario. 1 mass being greater than 2 being equal, or you could have this, but that's the same thing as 1, 2. And we know we can't have this or this because that would imply 3 different types of masses, which we cannot have because there's only blank or live. So Jack Sparrow can use, if he just picked 3 random guns and he compared them, I think you'd only have to use 2 comparisons, because then like you'd compare M1, like let's say M1 less than M5, M5 equal to M6, yeah, and then you would just have M1 less than M5 equal to M6. And then that would be number 1.2. So then you would know you're safe. You'd always know you're safe. But anyway, yeah, I don't think I'm missing any edge cases, but then again, this was like, this is just kind of an improv. I mean, I saw the clip like 10 minutes ago, so this was kind of a, impromptu, crazy, I haven't posted like 2 months type thing. Anyway, so an exercise to the reader from that I said earlier, which I wasn't going to do until just now, but the exercise to the reader would be redo this problem without axiom number 1. So anyway, pretty interesting stuff. I thought it was fun. Jack Sparrow can pick 3 random guns, and he will know if he's going to kill his daughter or not just by comparing a couple of them, just doing 2 comparisons. That's pretty cool. I don't know. I think it's neat. I think that's a cool example of math. But that should be everything because, and I'm not, by the way, when I take 2 guns, you can't determine if you're safe because I know like some people are going to be like, oh, what if you get M4 and M5? That's a case where you could determine a blank, but then even then, like, you'd have to do another 2 again to compare because you'd know only 1 blank. Anyway, I'm rambling. I need to stop doing that. I need to get better at cutting off my things. But yeah, so Jack Sparrow could pick 3 guns, compare them, and hope that the whatever pirate lord that he was trying to fight, or what, I don't know what's going on in the Caribbean, but whatever he was trying to fight doesn't end up just going, no, you can't do that, I'm going to kill you anyway, or like, I feel like this is kind of brazen actually to like, kind of like he wants you to do it off fate, and you're like trying to, discern, you're trying to see who threw his tricks. I feel like he might just, like he's not like held to any rules or anything. Like he could just kill you if he wanted to. I feel like that's kind of like silly. Okay, anyway, yeah, let's assume he's a nice pirate lord but also wants to kill your daughter. So, cool example of math.